Hello everyone, you're welcome to today's class. Today we want to look at structures in C. Now, what is structure? A structure is a user-defined data type that groups different types of variable under one name. So it's like saying Singapore as a country is, is not a natural country, is a derived country that groups citizens from China, from Malay, which is now Malaysia, from India, right, to form one country. So that is like a structure. Now, a structure is a data type, but a user-defined data type. You have int. So this is a data type. You have float. This is a data type. So then you have char. This is a data type, but these are primary data types. Now you can combine these data types together to form what you call structures, and then use the keyword struct to represent it. So that is what we want to look at in this class. So let's see. Now the syntax for structure is struct, then struct name, or yes, struct name, and then you have this. Inside it, you declare maybe data type member one, then data type member two. So we can have that. Then you close it. Because it is a statement, you will do this. Because if I say int A, I have to close this. It's a statement. I have to use my full stop, which is semicolon, to close it. So that is the same thing you are having here. Now, if this is the syntax, I want to declare a structure like this for you to see. So why do we need this structure in reality? This is used to represent a physical entity like book, employee, student. So that is what you use structures for. And this structure is actually the gateway to object-oriented programming, because what they now do in object-oriented, like Java and Python, is to take this part, then add the function, that is the method that will work on this data, to it and call it a class. So they now merge it together and call it a class. So that is actually what this does. It's a gateway. So we have been talking about Spirit, though one of my followers said I should stop using Spirit, that he doesn't understand. So Spirit, but I'll just use it in this class. Spirit, soul, and then flesh, right? So we are grouping this together as what? Body. So we can term this structure as what? The body. This is a data type, this is another data type, this is another data type, but you group them together as what? Body, which becomes an object in the physical space, right? That is the concept of this structure. So I am going to use this syntax to create a structure here. So I will say struct, right? Then I will name it person. Then I will close it here. Inside this place, I will say char, name. And I will say 50, meaning I'm allocating 50 space, 50 bytes in the memory. Then int, age. Then float, height. So I close this, and then I do this. So this is my structure that I've created for a person. So let us make man in our own image. He created them male and female. Then he formed man. So this part that you are looking at does not exist in the memory. This lives in the metadata of the compiled program, right? Just like you have every other data type, like integer or float. So what does this do? This will tell the compiler to allocate the size of memory for whatever object that will be created for this structure. So how will it do it? So it's going to allocate 50 bytes, right? Then integer is 4 because character is always 1 byte. Char, right, is 1 byte. Then when you say 50, so you're now saying 50 bytes. This integer is 4 bytes. Float is also 4 bytes. But if you add this together, this should give you what? 58 bytes. But if I ask you to find the size of this structure, it will probably give you 60. There's what we call padding. I'm going to teach you that in the next class, how you are going to create the memory allocation for this. I'll teach you in the next class. So this class is just to introduce you to this structure. So this is my blueprint, right? The blueprint, the template for the house that we are going to build. So this is my blueprint that I've created. This blueprint doesn't live in the memory. It lives in the metadata of the compile program. So with this, I am now going to create the object of this blueprint, right? So let's clean this up. This should be up, right? Or let me bring it up. So here I will say, let's write a full program to explain it. So I will say include stdio.h. Then here I will say include string.h because I might need my string functions. So the first thing you do when you are writing a structure is a data type. So the first thing you do is you have to declare the blueprint before any function. So here I will say struct person, right? Then I will say char name 50 bytes, int age, float height, right? Then I will close it. It's a statement. Now I am going to bring in my main function. So I will say int main function. Inside my main function, I will create the object for this structure. So to create the object, so this is a data type. So I will say struct person. Then the object will be what? I will just call it P. So this is like saying int P. Now, if I do this and I do this, meaning I have created the object and the object is what? P. So the data type is this one, just like this integer. So this is the data type. This is the data type that I created. And then I'm creating the object for the data type. Now, how am I going to access these members, the element of this structure? I'm going to use my dot operator. The dot operator, that's what I will use to access it. Now, two ways. I can declare this object and then assign values to them immediately. If I'm going to do that, I will do this. Then I will do this. For this name, I will just write etete, comma. This age, I will say 35, comma. And then this height, I will say 5.9, right? Then I will close. I will do this. I can do it this way. So that will assign this etete to what? To name, and 35 to age, and 5.9 to height. And then I can print it out on the screen. or I will simply leave it like this. I will declare it like this and then initialize it later. So I have created the object, which is the physical human being, physical object, which is P. Now, if I want to initialize these values, for this name, I'm going to use my str, that is string copy, and P name, comma, and then etete. Then P dot H, assign 35 to it. Then P dot height, assign 5.9 to it, right? So this is me. Then I can now print out by using my printf function. So what this is doing, this etete will be stored in the text slash code segment. So etete will be stored there, right? But this P name will be what? Here. This is stack. So P dot name is a local variable that is inside this function. So it will be here. Then you have to copy it to this place. That's why you're using string copy, to copy it from here to here. So you now have two copies of etete, one in this text, which is read only, and then one in this P name. Then you use assignment operator to assign value to P page. So that is how you've done that. Now you can now print it out by saying printf, right? I can say percentage %s is percentage %d years old / n. Then for this one, right, you will say P name. And then for this one, you will say P.H. And then you close my curly bracket, right? And then you will say return 0. You close this one. So this is my program for structures. So I created this, I brought this in. This is what? stdio for printf, input, standard input output header. So it's the toolbox that allow you to call the tool called printf. Then string h. Because of this toolbox, I'm able to use this string copy. So I declared my structure, which is the data type. This is the blueprint, right? This is the blueprint. Now, inside the main function, I created the object for this blueprint. And then I use that object to access this element of the blueprint and then assign values to them. So I come here and I use the printf to print it out. So this is going to give me, as an output, this will give me etete is 35 years old. So this is what will be printed out on the screen. Now I can ask it to also print out the size of this data type. So which means if I say it should print out the size, that will be what? Size of struct person. If I ask you to print it out, it's probably going to print out 60 bytes. Going to print out 60 bytes, right? So let's go to code blocks. Let me demonstrate this for you to see. For structure, you create the structure data, the structure, the data type, then you create the object for that data type, and then you assign values to the element, and then you can print it out on the screen. So that is what I want to show you as introduction into structure. So in the next class, I will teach you structure padding. So let's go to code blocks. So this is our code blocks. And I'm just going to demonstrate, run this script for you to see what I taught you on the board. So this is our preprocessor directive that we imported, standard io.h string, then struct person. This is the blueprint of our structures. Then here I created the variable of this blueprint, which is like an object of the blueprint. Then I brought in a theta as a name. So you can see here, I created this without initializing. So I had to use the string copy to bring it in. And then I assigned 35 to h and 5.9 to height. Then here I'm saying print out this. Then I'm also asking it to print out height, which is what? Float, this long float. Then I'm asking it to print out the size of the structure. So size of structure. So I'm going to run this script for you to see what the output will be. So you see, so that is what Etete is 35 years old. Height is 5.9 and size is what? 60. So that is what I told you. Size is 60. Now, if you are to count, you will have counted this name is 50 characters. H is 4 bytes, that is 54. Height is another 4 bytes, that is 58. So why is it giving us 60 as the size of the structure? So that is what I am going to show you in the next class. It's called structure padding, right? So this is what I want to show you in this class. I also told you if I don't want to do it this way, I can declare it this way, right? I can do this. Then I will simply remove this part. I will simply remove this part. I can do this and I will get the same output. So I can run this script again. You see, it's giving me the same thing, which is theta is 35 years old, height is 5.9, size of structure is what? 60. So I can declare the variable and at the same time initialize it. Or I can declare it alone and then initialize it later, right? So I can do that. So that's what I want to show you in this class. So till we see in the next class. Bye-bye.